All right, well, it's 7 o'clock, and welcome back to day two of Stormwater Awareness Week. And this is our first presentation of the day, and I'm so excited to have Luke Owen joining us from Georgia and talking about his title is Wash Bay Water Treatment is just like construction site stormwater treatment. And here's how. Boy, I can't wait to hear what he's got to say about this. So, Luke, we're going to give you as much time as possible, but if you tell everybody a little bit about yourself, your company, and maybe introduce yourself and then jump right into the presentation.
Sure. Yeah. Thank you, John. My name is Luke Owen. I was born in Colorado and spent most of my life in the Western United States. I lived in Colorado, Utah, Nevada, California just before I moved here. And I was in the Marine Corps from 77 to 81. And I'll talk a little bit about that in my talk here since water quality over there was so horrendous, even back then in the 70s. And so moving here, I learned more about stormwater. I live in Atlanta, just outside of Atlanta, Georgia. I live on Lake Lanier, as a matter of fact. And I've never seen so much damage historically and even currently going on in watersheds like I've seen here since living here. And of course, Georgia and many southeastern states receive a lot of water. And so it's been a real eye-opening thing. Now, initially, when I got started my career, I dealt a lot with processed water. So I was involved in design and installation of wash bays. And so as I worked here, I got actually laid off about 20 years ago when I decided to go ahead and start my own company. And that was an eye opener. That was kind of tough to deal with, but it turned out to be just a wonderful thing because I saw quickly as I started a stormwater training and consulting company that the similarities between water treatment are so the same. I mean, it's really remarkable. And I see there's a real disconnect I see in the regulated community about water treatment, about what our country has done to give us the kind of quality of life with the water that we have here. And so I spend a lot of my time sharing that with people. And so I can say I've been an expert witness in about 7 different court cases regarding erosion and sediment control stormwater runoff damages. And I incorporate a lot of that, how the legal community kind of blends itself in with compliance with these permits. And I share that stuff also in the presentation. So I'm a grandpa, and I've got grandkids. Taught my daughter how to fish when she was 2 years old and put a worm on a hook, and she's out there catching fish with me and my grandson too. So I love what I do, and I think it makes a big difference in our future is what I'm trying to do anyway. So with that, I think I'm going to go ahead and get things started. So welcome. I'm going to go ahead and get things launched. You might wonder, how is it that you could compare industrial process water treatment with construction stormwater treatment? And I think you'll find, as I already mentioned, that there are a phenomenal amount of similarities between them. And so we're going to talk about that. My experience in seeing the property damage here in this particular state from erosion and sedimentation for other people's property has been remarkable. And I train all over the country: Indiana, California, Colorado, Nevada, Missouri, all over. And I've never seen the number of lawsuits for property damage as I've seen here. And yet there's just certain basic principles that would be, if they were considered properly in the design, which I see in the population of people that are attending the course. There's a lot of folks that have your designers, or you're a regulator. You might be working for the state of California or another state, maybe even overseas as a regulator on construction sites, and even wash bay type things. And so I think in contractors as well, I wanted to mention that, general contractors, a few of you guys that have signed up for this, which hats off to you. I prepared this with all of you in mind. So hopefully this will make a big difference for you. Let me get, here we go. So the company I started here, the National Pollutant Discharge Elimination System Training Institute, is a company I started as a result of essentially being laid off and not knowing what to do. But I found a passion here since when I was here for a year, worked as a regional manager for a consulting company, and then I got laid off and decided to go ahead and started training companies. So and consulting. So it's been a great ride, and I continue to ride that wave here as you'll see. I wanted to I put a few slides together just to quickly go through this. It's 7 o'clock back on the West Coast, or it's 8 o'clock here in the Central. I'm here in Georgia, so it's 10 o'clock here. I want to encourage you to know that today, and you'll find this is true with the facts that I'm going to lay out, more than ever, we need you. If you're listening to me speak right now, we need you. You need to really understand your critical role for our future water quality in this country. And stormwater, thankfully, is the only thing we need to worry about, although we do have some processed water, waste, sewage type issues going on. For the most part, we've done a pretty good job as a country in regulating and putting together laws that have to be complied with for water quality. Stormwater is an issue in this country, much more so than other countries that are still dealing with sewage and processed water pollution. So we have a lot to be grateful for as we move forward in this presentation. I just want to start off with that. There are certain basic things when you attend a Zoom. I do quite a few Zoom meetings and recertification type courses. And so, there's a lot of distractions, and I just want to make sure that, you understand that, if you can, put your phones down and not be distracted by that, maybe turn them off, because this course will change your stormwater life. I really believe that, but it's something you have to work for too. So, get rid of those animals or whatever distractions you might have if you have to shut the door or whatever. And then also, it's going to be tempting maybe if you're working at home to be working on another computer. So I hope that you turn that computer off and that you really focus on this and let it impact you. And again, I'm still learning too. Every day, I'm very involved in this. I've got so many friends that are involved in stormwater. They share with me stories. A lot of the work that I do, I'm still learning things. But over time, I've learned quite a bit as well. And I'm hoping through what I share with you will make a big difference in your professional life and even your personal life as you share some of the stuff you'll learn about here today. I was born in 1958, and the world population back then was not near as lit up on the earth as it is today. It was roughly less than half. It was 3 billion people living on the earth in 1958. And now we have 7.8 billion people. That is remarkable. And think about the stress going on with our water resources. Today we talk about microplastics and other, PFAS and stuff like that. But the major toxic pollutants that really are, affecting us and affected us back then, we've really pretty much permitted in this country and done something about it. But the amount of water we have on Earth is kind of mounted up right there in that ball. And you can see it is getting a little more polluted. And because of the number of plastics, and because of the number of PFAS and all of these things that they're becoming more of an issue than certainly back when I was born, if they were even around back then. All the fresh water we have on Earth is basically in that little ball right there. It's about 3%. And then all the fresh water that we can use is about 1% or even less than 1%. And keep this in mind that if you're living in an urban watershed and you're downstream, you're drinking somebody's potty water that was treated. So even the available fresh water we have has been treated in this country. And so where I live at the top of a watershed, the Chattahoochee River watershed. People downstream from me down in Florida are drinking water that's been treated at least 3 or 4 different times by the time it gets to them. And they're still healthy, which is pretty cool. Yeah, we do have issues with the chemicals that we can't take out of a wastewater treatment plant or strain out of drinking water. But for the most part, we've done a pretty good job of keeping our water clean, thankfully, or we'd be a disease-ridden country like so many out there today. When you take a look at the United States, when I was born, we had less than half at 340 million. We had 170 million people living in this country, and now we're doubled. And look at the concentrations of people. 85% of Americans today live in watersheds that are managed by MS4s. So municipal separate storm sewer systems, the cities and counties that now have an NPDES permit, they got to comply with. It wasn't too many years ago, that we had rivers and even water that was so polluted that people were dying from it. Typhoid, cholera, dysentery in this country, believe it or not. Cholera was a big issue. Can you imagine dying from diarrhea just from waterborne diseases? About 9% of those deaths occurred here in Georgia. In 1958, when I was born, greater than 50% of all the rural families used outhouses. I remember as a kid using my grandma and grandpa's outhouse in Oklahoma. They weren't wired up, didn't have a septic system. And that's the way it was for many, many people back then. And then, of course, when I was 6 years old, 70% of all municipal sewage and 97% of industrial wastewater was discharged directly into streams and rivers untreated. And this particular picture, I'm sure you recognize as the Cuyahoga River, the River of Fire. We need to remember that that river was so severely polluted, they never, ever dreamed that it could ever be cleaned up. Yet today, you can swim in it, you can boat in it. It has 64 different species of fish living in it. And many people will say, well, that's the Clean Water Act, and just leave it at that. You can't leave it at that. It's much more than that. The Clean Water Act was actually passed in 1948. The Federal Water Pollution Control Act had no impact on water quality, although it did put in money for building wastewater treatment plants. It had some policies, but it really made a difference in 1972 when the National Pollutant Discharge Elimination System permitting program came to be. And if you're in stormwater, keep this in mind. In 1972, stormwater wasn't even on the radar when it came to NPDES permits. So we're going to talk quickly through the evolution of that. Now, as I've worked as an expert witness and done a lot of consulting, and as I train and try to get in the mind's eye of the people that I'm training, what a point source is and actually what the system is, it caused me to look into Wikipedia. And I've kind of modified just a little bit the definition of what a system is, because if we understand the system as it relates to stormwater, then we're definitely going to be able to understand how critically important it is to comply with NPDES permits and plans. So let's take a look at this. A system is a group of interacting elements called the SWIP, the Stormwater Pollution Prevention Plan. Many states call it that. Some call it a little bit different. That act according to a set of rules. Now, those rules are found within the permit, the NPDES permit. This permit, I found in my career, is one of the most misunderstood and underread documents that are responsible for water quality in the entire program. Most people don't like reading it, other than consultants. They have to and interpret it for their clients. It's super critical and critically important that we understand the importance of complying with that permit. It's expressed in its operation with common characteristics and purposes that include devices called best management practices. And in this case, we're talking about passive treatment practices for stormwater. When it came to processed water, we're talking about passive and active treatment systems with certain functions, behaviors, and interconnectivity so as to produce a predetermined result, which is real exciting because that is coming from a pipe, a point source, unpolluted water. In other words, we're treating the water on a construction site in an industrial facility, and we're discharging it after it's been treated to our watersheds. And that has made all the difference in America today. So the unifying principle behind processed water for wash bays and stormwater is NPDES. It is the National Pollutant Discharge Elimination System that has given us the water quality that we have today. And we have to understand the basic concepts that make it all work. Here we have 4 of them, and I've broken them down into different categories here. So we have to go beyond the basics when it comes to understanding what a watershed really is. Also, one thing I've found, people complain about mud in the road and they just don't want to see it. And so regulators respond to that and think, in their mind, well, this is just more or less a Clean Streets Act, but it's not. And we need to understand that, because it changes your mindset and your approach to how you tackle your regulatory responsibilities out there. It's not the National Pollutant Discharge Management System. We're going to talk in some about that, because of how sometimes regulators and people that are complying with an NPDES permit look at stormwater, they're just basically trying to get rid of it. Especially here, when you can receive a 1-inch rain event, that 1-inch rain event is putting on the ground 27,154 gallons of water on 1 acre. Now, that's a phenomenal volume of water. And yet when you get a 6-inch rain event, you get maybe a 3-inch rain event, that water is just wanting to get managed and shipped off site without treating it. We can't afford to do that. And then we have to understand and embrace the Clean Water Act's wisdom behind passive treatment and active treatment. So we're going to get into that a little bit. So, we all know what a watershed is, or you should. And if you don't, this is kind of a good picture of it. It's in an urban area. Here we have a river system. It's being fed by creeks and streams and whatnot. Look at that. Here it is, just beautiful. And so when we isolate that, that's kind of where we tend to stop talking about what a watershed is. But, in our urban areas, that watershed is connected with pipes and outfalls that are discharging from those storm drains. And in this case, becoming very severely polluted from just stormwater runoff from these outfalls. We have to understand that. So our definition of what a watershed is cannot be just left alone and thought basically as it's a river and a creek and a stream. And yeah, it looks blue. No, it doesn't. Not in an urban setting. We have to understand that and take responsibility for it. So as we're looking at and how we define in our mind a watershed, I hope you look at a watershed like this. And it's up to us to not look at it as the NPDES permit program as a Clean Streets Act. It's not that. It's easy to think of it that way when you take a look at pictures like this. And when you take a look at videos like this, where this contractor, as you'll see later on, received a pretty significant stop work order as they were discharging down to the storm drain, allowing that water to go somewhere. They had to kind of pull that over, let that go down so it fed the creek. Now, all these videos I took are just about 2 miles away from where I live, of the same rain event being discharged down to Lake Lanier. Now, this lake has got my little daughter sitting on the delta, or my granddaughter there. And I just want to mention this. She's sitting on a delta of sediment that 20 years ago, when I first moved here, I was fishing in this area. I could not catch a fish here. The long-term devastating impacts to our watersheds of sediment are very real. And in some parts of the country more than others, but sediment doesn't evaporate. It settles to the bottom and it covers the benthic environment. It kills fish eggs, macroinvertebrates. It holds on to heavy metals, makes them more concentrated, removes oxygen levels. I hope you really investigate the devastating impacts, the long-term impacts as well of sediment, because it is a really very real issue. This is just looking back on the pediment terrace that my granddaughter was just sitting on, the delta she was sitting on, as the water level's a little bit higher there. And that's the dock right there, and the sediment that's impacted his quality of life. Now, he can't sell that house for what he'd like to because it's sitting on mud most of the time. And it wasn't like that when he first built it. So it's the NPDES permit program is not a stormwater management system like these guys are treating it. As you can see, they're taking water down that drain, putting it right straight down there, even though the sign on top of that lid says dump no waste, drains to a waterway. Again, this is a client I was dealing with. I received a great big rain event. The individual that was responsible for installing sediment traps and diversions that would have prevented this rain event called in sick that week, and they didn't do anything about it. And they just happened to get a 4-inch rain event that made it look like this. We cannot afford to look at these as management systems. They're treatment systems. And that's the advice that I gave these guys, was to put in along the way as close to the source as possible of where that rain was falling and hitting, to infiltrate that water into a storm drain system or into the ground. And so it could run off properly and not cause any downstream impacts. So we can do it. Using anionic polyacrylamide in a case like this is a very effective way of removing pollution after you've done a lot of treatment beforehand. Something that many people are unaware of is the National Urban Runoff Program. Now, the National Urban Runoff Program was a program that studied stormwater as a pollutant source after we had already dealt with the processed water and like from U.S. Steel and these big, chemical manufacturing companies and stuff like that. We dealt with sewage and all that and did a really good job. And I'd love to have the time to be able to show you just how effective and how quickly that was reducing fish kills when we did that. But we noticed in the Clean Water Act, as we're continuing to, the EPA is continuing to study water quality issues, that runoff was causing a problem, but they didn't have any facts. They didn't have any proof. So they studied it from 1979 to 1983. And I think it's important to understand the difference here. Now, remember, processed water is treated with active and passive technology, where here they were trying to get to the bottom of whether or not urban stormwater runoff was causing problems. And in the event that it was, how are we going to treat it? So the overall goal of the National Urban Runoff Program, NERP, was to develop information that would help provide local decision makers, we can call those guys MS4s today, states and EPA and other environmental groups, with a rational basis for determining whether or not urban runoff is causing water quality problems. And in the event that it was, for postulating realistic, and that's an important word, realistic control options and developing water quality management plans. And what do we call those in the MS4 world? SWAMPs, stormwater management programs. What do we call them in a construction or industrial world? SWIPs, stormwater pollution prevention plans, consistent with local needs that would lead to implementation of least cost solutions. Least cost solutions. Now, since that time, even the federal government, EPA people have forgotten the intent behind the National Urban Runoff Program. It was to somehow determine, of course, that stormwater is carrying pollution, and they proved it. They studied that in 2,300 storms in 28 states across the country, got a bunch of data that proved it. But how are we going to deal with it? And they made a decision right up front to make it reasonable, to make it achievable, to make it feasible, as we're going to learn about what feasibility means here. But what that really meant in this case is passive stormwater treatment systems in the form of permits and plans. So the MS4 permit, the SWAMP, industrial multi-sector general permits, SWIPs, as well as construction permits are all going to have devices that passively treat water. Some narrative, like an MS4 permit, has 6 minimum control measures. Those are the narrative approach to passive treatment. And then we have other types of passive treatment devices that are vegetative and structural that we deal with multi-sector general permit and construction site activities. But again, 9 times out of 10, mostly passive, especially for construction sites. So 40 CFR Part 450, this is an important thing to remember, that the EPA came out, Congress came out and passed that the effluent reduction requirements, since we're going to use passive treatment technology, they had to define this as what's feasible and what's infeasible. What they found right up front is using Baker tanks as like an active treatment system to treat stormwater was not going to be feasible. So infeasible is what they gave it. So what we're looking at there on the left side is a detention pond, a permanent detention pond that's got a skimmer or a retrofit attached to the back end of it. It's got a forebay there. So a lot of treatment technology, passive treatment technology, has gone in place to treat that water prior to it going down to this discharge point. And that's our approach to treating stormwater. So the active treatment technology approach, essentially you can say, I learned from a good friend of mine years ago, became a good friend of mine, that basically hook it up to electricity, put it through filtration, flock it. You can actually put aluminum sulfate and that kind of stuff, as well as anionic polyacrylamide, as a flocculant with active treatment systems. They utilize electricity, though. That what they're doing is they're taking a water that's already been kind of pre-treated and they're treating it through an active system. An active treatment system initially requires passive treatment and is usually more expensive and less feasible. But then we got passive treatment technology. And here we have some applied polymers. I use some of their videos and whatnot. I worked with those guys quite a bit. Wonderful company, by the way. And so here we have passive treatment technology in the form of using jute and anionic polyacrylamide. But think about all of the work that had to go in to treating that water and removing most of the heavy soils, the particles out of it before it could actually be treated properly by this passive device. You know, the wisdom behind NPDES is truly, it's just common sense. And Benjamin Franklin said it best, an ounce of prevention is worth a pound of cure. So let's take a look at this wash bay scenario, and we're going to compare this to a construction site here in a minute. The industrial and municipal, system here, as you're going to see. Here we have a guy that's got a piece of equipment in here, and he's got a skidster that he's going to pressure wash. Now, if you notice, there's a lot of mud that are caked on this thing. Even the bucket has quite a bit of mud. Now, why would it make sense to bring in a piece of equipment into this wash bay and knock out all of that sediment that would completely fill up the trench drain and the collection pit? It wouldn't make sense. So when we built these wash bays, we also had procedures in place. We told these guys, okay, before you bring people or before you bring equipment in to pressure wash it, you got to take it out, move it out of there, wash it down, knock off all that heavy mud, bring it back in, so it's not going to clog our treatment system, our passive treatment system. So here in this case, we have check dams in this trench drain. Again, we're not using electricity at this point. We're just trying to remove the pollutant load as much as we possibly can. And again, we're going to compare this to construction site runoff here in a minute. And then we're going to, as you can see, it's got a little bit of sediment down below there. Then we have a collection pit and a 3-stage collection pit that's taking that dirtier water right up front. You see a little bit of sediment down at the bottom of it. And then it goes into the second stage and then eventually the third stage where it's going to pump it into this active treatment system that then is going to treat it through filtration, a lot of electricity, flocculation, and then it's going to discharge it. And in this case, they have to meet a numeric discharge limit. Now, that's true of all active treatment systems and wash bays like this. If they discharge to a wastewater treatment plant, they have to meet a numeric discharge limit. Now, there's a lot of narrative things that have to go on as far as inspections, changing out the media at a certain frequency and that kind of stuff to be able to get good, clean water. In this case, they're going to discharge it right straight down to a wastewater treatment plant that they're going to treat it passively and actively, and then they're going to discharge it to a wastewater or to a state water, or what we could call here in this case, a water of the US. That is the NPDES permit program in a nutshell that has given America the kind of water quality we have today. We take the example of a construction site and we realize pretty quickly that it's not going to be feasible, although we have to look at it as a treatment system, it's not going to be feasible to put it into an active treatment scenario. That sediment would not go well into a publicly owned treatment work. So what fills the gap is what we have to talk about. What fills the gap is understanding, first of all, how critically important it is that we look at construction sites from a phased approach. We don't take down all the trees or clear all that ground all at one time. If we can avoid it, to try to prevent that runoff, we have to talk about vegetative measures, structural measures that we'll cover later, because there's nothing to keep that pollutant, sediment being the number one pollutant here, from entering that state water like this. So here's a construction site. And, I hope that by attending this course, that when you're talking to people in pre-construction meetings and you're talking to your work associates, if you're talking about the NPDES permit program, you're not talking about a construction site. You're talking about a stormwater treatment system that has an operational permit and a SWIP, a stormwater pollution prevention plan that has to be implemented from NOI to NOT. That passive stormwater treatment system is represented in the SWIP, and that includes vegetated ground cover, structural measures like silt fences. Now think about vegetated cover. What are we doing there? Remember when that piece of equipment pulled out of that wash bay and we brought it back in a little bit cleaner, although it still had some pollutant on it? That's what we're doing with vegetated ground cover. We're trying to prevent that pollutant load from being exposed so it doesn't overwhelm our perimeter controls, our storm drains. Because if you don't do a good job of preventing the pollutant from being detached, then you're in trouble. Then your structural measures cannot possibly handle that volume of water that we talked about. So silt fences, inlet sediment traps, channel stabilization for extra volume and velocity, flocculation, passively treated, and collection pits, sediment basins are all implemented so that we can discharge that water through narrative. And in this case, where I live in Georgia, believe it or not, some states, if you're here from Washington State and some other states, you do have a lot more frequency of using numeric discharge limits. Some parts of California now not only just have sediment or total spended solid type limits, but they also have, heavy metal type discharge limits and stuff like that. And so, of course, we're treating that water so it can all meet a water quality objective as it goes to our state waters or water of the US, depending on how your state is operating there. So here's a construction site. We're looking at it as a point source that's being controlled with a permit from NOI to NOT. The SWIP and the BMP inspection reporting requirements are all found within it. We have the design that has to be installed and maintained properly right up front. And that designer is either going to be a PE, somebody that's qualified within the state, could be a CPESC, maybe a geologist. In this state where I'm from, a number of other professions can actually be the designers of record. They get done with that design and they give it to the plan reviewer. Generally speaking, a government representative, it can be local or state. They're going to review that plan and then they're going to allow it to be released where the operator of that treatment system is going to be implementing it. Now, in our state, they're required to be certified. Some states, I'd say most states, do not require that superintendents, the operator of these facilities, are certified. I think they should be. I think it's a super critically important position, understanding that they're the ones making decisions on implementing BMPs and whether or not they're going to spend the money on that. We need to have those guys certified so they understand their position. But many states do have certification requirements for people that do inspections. So those guys are trained. And then they have subcontractors that many times are not aware of even this being a stormwater treatment system. They need to be educated so they don't end up getting their client in trouble as they're actually, maybe out there stripping buffers or grading in areas that they shouldn't, maybe working out of phase and that kind of stuff. And then, of course, we have the regulators out there that are going to be enforcing all of this. So in our pre-treatment here, this is a project not too far from here. A friend of mine's actually doing the consulting work on this right now. Look at how phenomenally well covered this site is. Now, what you're looking at in the background is Lake Lanier. And they're maintaining this site too, which is real exciting. So they not only installed it, that ground cover, mats and blankets, they've got, any number of, they've got in other places, they have, it's already growing grass, they've got vegetated cover. So anyway, that's the first step. The things that we have to understand are just the basic things. Now, the treatment system of permits are complied with and are super important to be complied with. One thing is these treatment systems, and I wish I had more time to really spend on this, but we have to understand that all the work that we do in design, that job that you have where you're a civil or you're doing that, you're the designer of record, all that work, I'm sure you've been frustrated when you're doing your site visits and you take a look at these sites and they didn't even install them right. And you put all that effort into it. You have a responsibility of doing a good job on those plans, but also making them understandable by the people in the community of people that are the superintendents that are installing and doing the inspections on these jobs. Anyway, there was a study done by the EPA. Cheryl Wasserman, in this case, was employed by the EPA at this time. And they were trying to figure out, how do we get people to comply with these permits? Is there going to be a fear of enforcement from the EPA or the state, or what's going to be the motivating factor? And what they found through their study is that 5% of the permittees out there will always violate their permits. Good news is 20% will always want to comply with their permits. But this is where it becomes so critically important. If you're a state regulator attending this course, your role has never been more important. And it's a human nature thing. If you're involved in these projects and you're making regular site visits, then these guys are going to comply, because 75% of permittees out there will only comply with effective local enforcement. Super important. One thing to keep in mind, where I live in this state, and I'm sure it's true and where you're from as well, the powers that be, whether they're the mayor, the public works director, the people that are making these decisions on how to enforce these regulations that they don't even understand. One thing about it is the closer you get to the pollutant source, the more it costs the polluter. That's a fact. If you don't focus on getting responsibility on those polluters, then it's society that's going to end up paying for it. The further you get from the pollutant source, the more it costs society. We have to understand that. And society doesn't normally feel those impacts long term until it's too late, maybe even a generation away from where we're at now. You've got to contain the pollutant as close to the point of origin as possible. In that wash bay where we had that skidster, that piece of equipment there, you noticed he was located at the top of where that trench drain was. You can get that raindrop on a construction site to soak in at its point of impact. You've killed the beast. So we're trying to contain that pollutant as close to the source as possible so your sediment control structures can do their job, right? So stormwater treatment system permits only work when they're complied with and enforced. Stop work orders, unfortunately, are a necessary evil because that does get the attention of the people that are out there that have mobilized equipment. They're paying employees. They don't want to keep this site down. This is an example, the very same site, all three of those photos of a job not too far from here that got a stop work order because of some complaints. And look at the phenomenal job they did of stabilizing those soils and controlling that runoff with structural measures. Third point, the pollutants of concern so they don't become a water pollutant. Stormwater management. Here, take a look at this. This is just looking at oils. It even looks like they maybe even changed the oil out here. We have an asphalt pile, a lot of PAHs in that stockpile there. Well, it rained and it went down to on the construction site, and look at that oil on the surface of that water. Wildlife is swimming in that water. And not only that, the skimmer is discharging it directly to the state water. This is a mindset of stormwater management and not treatment. We cannot afford to look at our sites like that. Here's a job I was involved with. I told them, take this sign down. They had a pond and they just needed to dewater it because there was an expected storm to come here. So they just discharged it, called it stormwater runoff, even though it wasn't raining. No, that is an illegal discharge of a pollutant into a watershed, into an MS4 that actually discharged it directly down to Swanee Creek. Cannot look at sites like that. So here we go. This is, again, just kind of an example of stormwater management and not stormwater treatment. Intentionally dewatering a site with pollutants in it. Again, this is a site, these guys ended up paying about a $500,000 fine. They settled out of court simply because they did not install any BMP, very few BMPs. Where that water was leaving, there should have been a detention pond and they didn't install it. Okay, then we have the volume and the velocity of the pollutant load that we have to deal with in the design. We have to deal with that in the installation of our BMPs. Also, I think one of the most critically important tasks we have out there is maintenance. People don't like to maintain. The bottom line, they just don't. I don't care what it is. It's not just construction. It's process water bays too. When I was installing these wash bays, we're talking about a company that just spent maybe $100,000, $200,000 on a piece of equipment. Process water equipment, talk about an active treatment system. And we knew that if they did not clean out their trench drains and their collection pit, that pump was going to be pumping a lot of very dense oils, greases, and sediments directly into this active treatment system that was very fragile in terms of what it could take. Active treatment systems have to have a lot of treated water go into them before they can actually operate correctly. Anyway, I would install these systems and the plant managers every single time, and I'm not kidding you, I installed like 6 or 7 of these. Every time they said, no, the guys in the back will take care of it. The guys that are pressure washing, they'll clean out the trench drain, they'll clean out. And I mean, I was volunteering, not volunteering, I was trying to get a maintenance contract with these guys so that we could go in on a regular basis and clean out the passive treatment technology so their active systems would work. No matter how well I tried to explain that to these guys, they wouldn't do it. So as a result, I'd get a call about 6 months later, cussing me out because the active treatment system wasn't working. And the first question I'd ask them is, did you clean out your passive system? And every time, no, they didn't. So you have to understand the importance of looking at these like a wash bay as a combination of passive and active technology. But just as importantly on a construction site, all those passive systems, if not even more important, have got to be operational. They've got to be able to deal with the kind of water they're getting hit with the load they're getting hit with, so they can discharge clean water from the outskirts or from the perimeter of their sites. So we have these three big bad stormwater management challenges, and this is the volume, the velocity, and of course the pollutant, the increased pollutant load. In this case, you see in the background that stormwater is hitting, it's picking up through different various forms of erosion, a lot of sediment. And that is the one that gets the attention from most people. But you as a design professional, you as a installer and maintainer of BMPs, and you as a regulator, you've got to understand you need to address the pollutant load and the complaints you get, but you really, just as critically important, have got to deal with the volume and velocity issues, because they're what carries the pollutant. They're the ones causing the damage of that pollutant and allowing it to get off site. I'm not going to go through a lot of details here. I think by the time, this is a kind of a basics course, but, there's one form of erosion on construction sites that typically provides the most sediment load. And I'll cut to the chase and tell you what that is here really quickly. But splash erosion exposes that, again, detaches that particle, and then when it sheets off, and here we have on the right side, look at that. That area there in the foreground is all sheet indications of sheet flow or sheet erosion. Take a look at that. And now you have the sediment that's built up in the background because that silt saver kind of slowed that water down, reduced the volume, reduced the velocity, that allowed that sediment to drop out. This is a really perfect example of what can be done if you properly design, install, and maintain your BMPs. You can see what sheet flow does here as well. It takes a lot of sediment and leaves the rocks on top because they're too heavy to be carried along with sheet flow. So there's an awful lot of dirt that gets carried along while the rocks just stay put. Oh, and here's where some water really did waylay this silt fence. Now this, as I mentioned yesterday, was in great shape. But as you can see, even though we do have a lot of rock in this, I'm going to put a stop on that right now. And by the time water gets to the perimeter of a site like this, it's too late. They did use the wrong type of silt fence. There's no question about it, called the sediment barrier. But the water volume and velocity, regardless of how well you put in a silt fence or you put the right type of silt fence in, that same water volume and velocity is going to hit that site if you don't do something upstream interior to the site, right? You've got to slow down that velocity. You've got to reduce that volume, use diversions, do things that are going to help your perimeter controls work. Here we have on the left side, lower left here, the rills, of course, that are created here. And this eventually did form a pretty good sized gully. And we even have some gullies that are being created right here. We have a lot of rock in this subbase right there. And then, of course, a gully right there. So we have the four types of erosion, but keep in mind the importance of the splash and sheet erosion. Reducing volume and velocity and the pollutant load by ground cover and phasing projects is a really critically important thing to consider in your operational considerations. Here we have a detention pond with a skimmer, properly installed, looks beautiful. But again, we got to realize there's been a lot of water treatment that has taken place before the water entered this collection pit for this to really do its job. They did install it properly. It's on a hard base, but we have to understand the importance of treating that water as close to the source of impact as possible. So let's talk about what has to happen before the collection pit and then what has to happen also in the collection pit. I've seen a lot of damage of BMPs in the collection pit. You have to prevent erosion before the basin, right? We talk about preventing volume and velocity and pollutant load impacts there. And then we have to expedite that sediment deposition before the basin as well, as much as we possibly can to help our collection pit do its job. Here in this case, we got to prevent erosion of the basin because if we have fast moving water moving into this basin, we're going to get a lot of erosion on the bank. So actually, and we've got some good stabilization here. You can kind of see in the foreground here, just where the outlet structure is, good stabilization there. And then we have to expedite that sediment deposition in the basin. So we're going to kind of go through the process here real quickly to kind of go through this as the water hits the ground, how we first of all have to focus on preventing erosion first, dealing with volume, velocity, and the load. And then as it moves to the outskirts or the perimeter of our site, then we've got devices in place that'll cause that deposition to occur in a manageable way. So we have two primary concerns: prevent erosion first, control the sediment second. I love this photo here. This is just a timber harvesting area before construction. So we're going to be preventing sheet flow and splash erosion by just keeping the trees out there. We have to be somewhat concerned about mobilizing, about the cost of mobilizing. The people we're regulating out there, the people we're designing for are very cost focused. They're not looking at their construction site as a treatment system. You're just a pain. My whole career has been making a living as a necessary evil. I'm helping people comply with the permit, and in some cases helping them after they got in trouble for not complying with the permit. It's an important thing to realize that we have to first of all prevent the load from getting exposed to the treatment system. And if we can do that effectively and cost effectively, the happier our client is going to be. So understanding the limitations of a construction site schedule working in concert with an NPDES permit, there's significant conflicts here. They're going to be butting heads. We cannot cave to profitability and being sympathetic to the polluter. We have to hold them in compliance, right, with these permits. Because if we don't, 75% of permittees out there are going to violate the permits. We have to help them comply. Pre-construction meetings are really important about that, helping people understand that. How the NPDES permit program works. I know I'm covering a lot of information here quick, trying to get it all done. If we cannot just focus on, eventually we're going to have to take those trees, we're going to have to start grading this, and then we want to stabilize those soils as soon as we possibly can. Prevent that erosion as much as we can. And then here we have a silt fence there in the background. This is something I learned on a job here. This is not talked about very often. And regardless of where you're at in this country, I think if you can take a look at a structural way of preventing erosion, it'll really behoove you. Here we have a compactor. Now, the type of soils here are saprolitic soils, but if you have a real coarse grained sand, you roll it with a compactor, not to compact the soils. You're not doing it for that intent. You're doing it to imprint into the soil. So where rain hits the ground, it's going to hit, and as it starts to sheet flow, it hits a sediment basin. Thousands of them that allow that water to soak in. Isn't it? I mean, what we did here on this is about a 3-inch rain, 3.5-inch rain. Our perimeter controls were golden. We didn't have any blowouts at the ponds. The silt fences were in great shape, all because of what I learned from this superintendent who taught me this. This is a church being built about 5 miles from where I live right now. Massive parking lot. He did a phenomenal job of preventing that volume and velocity and load from getting exposed. Here's another way of preventing erosion. Here we have tackifiers on the left side here. This is from a Florida Stormwater conference a few years ago. If you're one of my friends from Florida, you may recognize this. Look at how we prevented erosion there on the left side. Now these trays have the same type of soil, same type of rain hitting them, same volume. But think about the amount of maintenance that's going to go in on a job that doesn't prevent erosion. Tackifiers are phenomenal. Polyacrylamide, anionic polyacrylamide in this case, being facilitated and help with a jute, 4-inch jute mat being laid on the surface there, preventing erosion. Capture sediment loads upstream from the sediment basin as much as you possibly can, just like you saw in that active treatment system with the check dams that are in that trench drain. We want to try to slow that water down and stabilize our pit, stabilize our channels rather. Here they're using sod. So whatever we're going to do, they're going to prevent erosion of that concentrated flow area, allowing the water to pile up behind our check dams to allow sedimentation to occur, slowing the volume velocity and preventing and removing the load before it goes down to the outlet. So we want to capture that sediment up front. Here's storm drain protection within the site. Again, that storm drain is going to be going directly to the perimeter. And then we have interior silt fences here that prevent that sediment from getting on that hard surface. And then, of course, check dams along the way. Eventually, it's going to get to the collection pit. And here we have different components of a collection pit that we need to consider. This particular photo, if you guys have a chance, I'm going to put a plug in to Auburn University. Mike Perez, Barry Fagan. These guys have done an amazing job in putting together a test training facility in Auburn, Alabama. Regardless of who you root for in football, I really want to encourage you to go down there. They have about, I think, 2 events a year, maybe more, that you can go down and you can learn about how these devices work. UNC, University of North Carolina, also has got some really great facilities. I'm actually going to be going to South Carolina here next week to learn a little bit about some more BMPs out there. Anyway, here we have in a collection pit, and we have these baffles inside of this collection pit, what we could call filters as well. Look how well stabilized this is. Look at the concentrated flow area coming from the forebay over to where the outlet structure is. And of course, you can see there to the left of where it says emergency spillway, you have a skimmer that's going to be floating on the surface after that water's been treated, so it can actually discharge a lot cleaner water. Now, in my state, we have discharge limits that we have to respect. And when the skimmer surface water outlet, structural outlet technology became a federal mandate about, I want to say 2017, I immediately was concerned about how Georgia's permittees here were going to meet discharge limits, because we have a discharge limit for our construction sites where most states don't. Even the technology where this was used in North Carolina doesn't have discharge limits, but we do. The only way a skimmer can really discharge clean water to meet a discharge limit for total suspended solids is if you use a polymer, if you have a lot of fine clays. Anionic polyacrylamide is a real important thing to remember for water treatment. And I've got a lot of experience with that here in this state. And through all of this, maintenance, proper installation, maintenance. This is just a great example of a guy that just looks at a contractor looking at these things as stormwater management, necessary evils, not giving it any attention. That skimmer is completely stuck in the mud. Here we have, though, and in the background, we even have a forebay. We have good shoreline protection. And as long as we maintain the sediment, get that sediment out of that forebay so they can actually properly treat that water so it doesn't overwhelm the rest of the collection pit for its discharge, we're in good shape. As concentrated flow areas go into this forebay, into this collection pit, we want to make sure that we have good protection to not prevent erosion of the basin itself. Here's another picture of the forebay, freshly installed. The only thing they had problems with in this install, they didn't do it according to the design, is they needed to stabilize the dam here. They didn't stabilize it through its entirety, just that concentrated flow area. And what happened is over time, the whole thing fell apart. And that's a good example of it right there. So, but forebays are there to remove the heavier loads first. It minimizes maintenance, maximizes polymer reaction with the colloids in the second stage when using polymers. Filters can be impregnated with anionic polyacrylamide as well. Now, I don't have time to get into details at all with anionic polyacrylamide. There is a great amount of information out there right now. And I want to remove your fear about using a polymer, anionic polyacrylamide in particular. Even on the EPA's website that they promote it, a very environmentally safe and a really great way of knocking out total spent solid mass before it goes to a state water or a water of the US. Here, this is porous baffles. This was Rich McLaughlin. I got 5 minutes left. Rich McLaughlin actually put this up when he was actively working. I think he's retired now fishing. But he kind of showed just through dye what filters do. Now, we're not even talking about using polymers at this point, but if you've got anionic polyacrylamide sprinkled on these fences, on these jute membranes, then you're filtering out sediment along the way. Keep in mind, the more effective you are at filtering out sediment, the more maintenance it causes. You know, we can get clean water. Point source programs are phenomenally effective. Look at how it's spreading the energy out here. But they're only effective if the permits are complied with and if they're properly enforced. We don't have time to go through this video, but I want to encourage you to look online, download videos, learn a lot more about using anionic polyacrylamide, keeping in mind, if you're going to use it as a flock log, you've got to do a lot of water treatment, passive water treatment first on a construction site before it can actually do its job to knock that load out. And then, of course, you know, our skimmers, we do have that federal mandate that now most states do implement. I know in Region 9, they do not implement it in their NPDES permits for good reason. I just want to mention, you know, Georgia gets about 4 inches of rain on average a month. Nevada gets about, and Las Vegas in particular, gets about 4 inches of rain per year. So a lot of what I talked about here for stormwater treatment really may not apply to you, but I do want to encourage you to look into using, for arid areas, people that are in arid areas, use anionic polyacrylamide as a tackifier to keep that windblown dust down. It works really, really well. And as you're looking at, and as you're considering using skimmers, some things that we've learned here that are, you're not going to find in necessarily any manual, certainly not here in Georgia, but I put in here a control valve, and that control valve's connected. So, and it's off. It's got the control valve is closed down here. You can use a really more of a control gate is more effective. But here you have the water been treated with polymer that allows deposition quickly. And then the open up the control valve, and then that water is released at a controlled rate so you can meet a discharge limit. It's getting the superintendent to just spend a little bit of time or getting one of the subs out there to open and close these valves. Some work better than others. So I hope that by attending this 1 hour blitz on how to compare a wash bay with construction site, essentially all I'm saying is that water treatment is uniformly, the technology might be a little bit different, but the techniques are the same. You've got to reduce load first as close to the point of impact of water as possible, and along the way treat it so that you can meet discharge limits, whether they're narrative or numeric, to preserve our water quality.
Well,
So
great job, Luke. We do have a couple questions that we only have like a couple minutes, but if I could field some of them to you real quickly.
Sure.
Okay, so just comment, in my state, the LRP is the one being fined rather than the contractor who's creating the problems. A lot of the owners do not understand the NPDES or the means and methods of a contractor, but are responsible for the contractor's negligent acts. Why aren't contractors being fined for these violations?
Well, you know, without really looking at their permit, but the bottom line is this: you know, whoever signs that notice of intent is the permittee. So now let's say that a general contractor signs it for the owner. Then initially the general contractor is going to be the operator for that site, and they're responsible. However, if for some reason there's some financial deal, they get fined a lot of money and they go insolvent, then the owner will always be responsible. the owner of that property, and you could say the treatment system itself. So in the Clean Water Act anyway.
Okay.
So, yeah.
Good. Well, if we had other questions, but unfortunately we're out of time. How can people get a hold of you? Do you got a final slide there?
You'd think I would.
Right behind you, I see your website, npdstraining.com.
That's it. And my email address is TLOwen for Thomas Luke Owen, TLOwen at NPDEStraining.com.
All right.
NPDEStraining.com. Thanks so much.
Well, thank you. This has been a wonderful workshop, and I will recommend that anybody watch this and recorded. This has been very good. So thank you for joining us, and each of you that participated, thank you. We're going to have to let you go so you can get to the next workshop. So thank you for attending.
Thank you.